Unit 12 was on circles. This was the unit that we covered right before spring break. And so some of you may have forgotten the different parts of a circle are different types of angles inside of a circle. There are two types that you really have to know. The first one is called a central angle. And I'm going to, let me put a letter here. I'm going to put a letter O right there. And I'm going to say angle WOP is a central angle. It is 130 degrees. WOP, this angle is called a central angle. It's because the vertex is at the center of the circle. When there is a central angle, the arc that is intercepted is equal to, I'm going to put arc, WP, is equal to the same degrees as the central angle. This angle and this arc are the same degrees. That is the thing that a lot of people got confused, because there's a different type of angle, an angle called an inscribed angle. The inscribed angle is angle WTP. I'm going to put inscribed angle. So the inscribed angle is an angle that has the vertex or the corner of the angle on the edge of the circle. If the vertex is in the center, it's a central angle and they are equal. If the vertex is on the edge of the circle, it's exactly half of the arc. What does that mean? That means that this angle is going to be half of whatever the arc is. 130 degrees, half of that is about 65 degrees. And that's our answer for number 1. You are expected to know that central angles are equal to the arc and inscribed angles are half. And almost all the questions are going to be based off of that kind of fact. They're going to use those two facts and they're going to use this other fact. The fact that in a whole circle, it's 360 degrees. With a diameter, it's half of a circle, it is 180 degrees. So every other problem that is on this piece of paper, you are going to use 360, inscribed, central angles. The only other thing that's on here that's a little bit different, let me show you. Let me look at number 2. It kind of cut this off, but this is circle O. That means this is the center, circle O. That also means that this angle here, or this, not angle, I'm sorry, segment, KG, goes through the center. That must be a diameter. And so when I look at this, if this is a diameter, then that means that this is a half of a circle or 180 degrees. Yes, thank you. I'm going to put 180 degrees here because it's a half of a circle for this arc. That's going to make a difference. If this is 84, earlier we called that a central angle, which makes this arc 84 degrees. KB is 84 degrees. And so now that I see that this is 180 and this is 84, then this other arc, BG, and this 84 has to add up to 180 degrees, or they all have to add up to 360. So I'm going to do 180 minus 180 minus the 84 just to see what's left over. Use my calculator for that. 180, 84, 96, that makes a full circle. But what are we looking for? We're looking for angle BKG. B first, then K is the vertex, and G is second. We're looking for this angle right here. Bless you. If we're looking for that angle, here's your arc. This angle has the vertex on the edge of the circle. It is inscribed. Because it's inscribed, is it the same or is it half? So it's half of 96. What is half of 96? 96 divided by 2. 48. That angle for number 2 is 48 degrees. And this first one was 65 degrees. Almost all of your problems will be dealing with something along those lines. If it doesn't go through the center, it's not 180. This is not 180, right? Because it doesn't go through the center. But this is still inscribed, and that's 32, so you should be able to figure out the arc. And they all add up to 360. That's how you're going to do number 3. Now there's a few things on this worksheet that did not come out very clear, so let me help you. Go ahead.
So I have a question for number 3. Would it be double 32?
Yep. Okay. She's asking, is this arc double? Yes, that's not what they're asking for. They're asking for x. But you have an inscribed, which is half of this, or double that. And now you know what the distance is from here to there, and the whole circle needs to equal 360. You probably should just do 360, subtract that, and subtract that. I'm not going to work that one out for you. There are some true-false questions. I think you guys should be able to answer those. But in this picture, I want you to see 6A came out really, really bad. Here's what it looks like. There's an O, and what's supposed to be here is a line like this, and there's supposed to be a line like this, and there's supposed to be a 90-degree angle symbol there. It did not come out very well at all. So I'm going to help you with these two, number 6 and 6A. Number 6 says, write the formula used to find arc length. If you want to find this distance, not how many degrees it is. If I want to find out the distance, do I have an extra seat? Yeah, that's fine. If I want to find this distance, I have to use a formula, how many degrees out of 360 times 2 pi r. The measure of your arc divided by 360 times 2 times pi times the radius. It's like saying I want the percentage of the circumference. Well, what is the circumference of this whole thing? We're going to figure out how many degrees out of 360. If I look at this, I'm going to say it's 90 degrees out of 360. Times by 2 times by pi, and r stands for the radius. The radius here is 16. If I know that 90 divided by 360 is 1/4, because 9 goes into 36 4 times. 2 times 16 is 32. 4 goes into 32 8 times, or you can plug all that into your calculator. I still can figure out that this distance is 8 pi centimeters. Now, before I forget, I have talked to all the Math 2 teachers. The plan right now is that the final is going to be worth 1 test score, and besides that being worth 1 test score, the formulas will be given to you. Some teachers are doing make a formula card. Some teachers are doing an index card. Mr. Paramo is going to do I'm going to make a formula sheet of all the formulas, and I'm going to have that available to you. So you will not have to memorize these things. You just have to know how to use them. And there's going to be a bunch of them, so you have to know which one goes to which. Keep that in mind. And the back side. There are a couple pictures that did not come out very well at all. in the picture for 7a, it also messed up. So I want you to connect from here to there. You go up a little bit in that picture. From here to there. And then there's an arc that goes like this, saying that that is 210 degrees. They are asking you to figure out what the area of the shaded region is. Compute the area for sector DOE. How much area is this? That's what they're asking you to find. If you don't know, area is different than arc length. So it's a different formula. The area for a sector is how many degrees? Very similar to what we had before, divided by 360. Except because we're talking about area, it's now pi times the radius squared. You would do the exact same thing as we did on the other side, except we're squaring r instead of 2 pi r. So what I hope is by going over those things, you're going to know how to do what's on Unit 12. I'm going to give you guys some time right now to work on it, and we'll stop your notes right there.